Good morning. My topic is cone. First, we can see what are the contents present in the cone. First, synopsis we can see about cone. Next, nectar of a cone. The properties of the cone. Next, examples for cone. Next, volume. Formula for volume. Then, surface area. Formula for surface area and the lateral surface area. First, we can see what are cones. A cone is an n-dimensional geometric shape that tapers smoothly from a base to the point called the apex or vertex. In the diagram you can see in that picture, in the base it is circular shape and the point in the upper point is called the vertex. Next, if one end of a line is rotated above the second fixed line while keeping the line's other end fixed, then a cone is formed. Next, the point about which the line is rotated is called the vertex and the base of the cone is a circle. In the diagram you can see the base is the circle and the upper point is called the vertex. Next, a cone is said to be right when the vertex is directly above the center of the base. Then, when the vertex of a cone is not vertically above the center of the base, it is called an oblique cone. Next, we can see about the net of the cone. Here, the net of a cone consists of two parts. In the picture, you can see the first one is the circle that gives the base, and next, the sector that gives the curved surface. Next, the properties of a cone. First one is the cone has a circular base and a vertex that is not in the same plane and a base. Then in a right cone, the height meets the base at its center. In the picture you can see the height meets the base at its center. Next, the height of a cone is perpendicular distance between the vertex and the base. In the picture you can see that the height in the middle, the height of the cone is the perpendicular distance between the vertex, the above point, the vertex and the base. The slant height of a cone is the distance between the vertex and a point on the base edge. Examples of the cone. First one is the birthday cake cap. It is in the cone shape. Then the horn sound cone. Then the temple gopuram, that is also in the cone shape. Next, we can see about volume. First, we can see what is a volume. The space occupied by a 3D object. Here in the picture you can see the 3D objects. The cone, cuboid, sphere, cube. These are the 3D objects. The space occupied by this 3D objects is called the capacity of that object or volume. We can see next. We can see the formula for the volume. The volume V is equal to 1 by 3 pi r square h cubic units. Here r is the radius, height h is the height. Next we can see surface area. Any 3D solid is made up of flat or curved surface called a face of a surface. In this picture you can see the rectangular prism. In that the upper flat surface is called the face of the surface. Next, these surfaces are 2D and enclose an area. The area of all faces together gives the surface area of the cone. Next, we can see the formula for surface area. Surface area of a cone is area of sector plus area of circle. Area of sector plus area of circle is pi r L plus pi r square. In this we can take pi r commonly outside and we get pi r into r plus L. Here r is the radius, h is the height of the cone. Next, L is the slant height of the cone. Then we can see the lateral surface area formula. Lateral surface area is equal to surface area minus area of the base. Here already we studied surface area pi r L plus pi r square. We can use this here. pi r square plus pi r l minus area of the base pi r square. We can cancel pi r square minus pi r square and we get pi r l. Next we can see word problem. First, the radius of a right cone is 3 cm and its surface area is 24 pi cm square. We should find the height and the volume of the cone. First, here already surface area is given 24 pi cm square. So we can use the surface area formula. We have studied already. Surface area is pi r into r plus l. Here already r is given in the question. Radius is given 3 cm. So by applying this radius and the surface area, we can find the slanting height. So we already know L is the slanting height of the cone. So we can find the slanting height of the cone. Next, by using the Pythagoras theorem, we can find the height of the cone. Then we can apply the height value in the volume of the cone. We already know volume of the cone is 1 by 3 pi r square h cubic units. So we can apply the height and radius in the volume of the cone. Then we can find the value for volume. The solution is height is 4 cm and the volume is 12 pi centimeter cube. The second question is the radius of a cone is 5 inches. And volume is 100 pi cubic inches. We should find the slant height and the surface area of the cone. This is as opposite as the first question. Here radius is given, volume is given. So we can use the volume formula 1 by 3 pi r square h cubic units and radius 5 inches, and we can find the height of the cone. Next, by using the Pythagoras theorem, we can find the slanting height, that is L. We can find the L of the cone, that is slanting height of the cone. Then we should find the surface area by using the formula pi r into r plus l square cubic units. So we can get the solution as slanting height 13 inches and surface area 90 pi square inches. Next one is in a cone, h height is given 3 cm. Then the lateral height is also given 4 cm and the diameter is given 14 cm. We should find the surface area, lateral surface area and the volume. First, we can find the surface area. We already know the formula, surface area formula. Pi r into r plus l, where r is the radius, l is the slant of slanting height. So we can apply that in the formula pi r into r plus l square units. We can apply this and we can get pi 24 to 42 square centimeter. We can apply for pi, we can put 24 by 7. Next, we should find lateral surface area. We know lateral surface area formula is pi RL. So we can apply the radius and the slanting height 4 cm in the formula, and we can find lateral height as 88 square centimeter. Then volume of the cone. We know that volume of the cone is 1 by 3 pi r square h cubic units. So we can apply the height 3 cm. Then radius 7 cm from the diameter 14 cm. We can find the radius 7 cm and we can apply. We get 154 cubic centimeter. That's all. Thank you.